Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I think I'm slightly off center. Let me just, nope, other way. Something like that should be okay. Hey, thanks so much for being here. Train Jumper, MRS, thank you guys so much for coming in. And anyone who might be lurking in chat, hey, thanks for being here. Neon to Pudding, thank you so much for coming in. Hey, how are you? Right, so I'm back to streaming. We'll see how this goes. At some point, people will probably give me a noise complaint, and then I'll probably, my landlord will threaten to kick me out, and I'll say, hey, you know what? I don't mind being, moving out. So I think it's okay. The more I think about it, the more I kind of feel like getting a noise complaint wouldn't be the worst thing in the world, Like, it's probably okay. Maybe try play board game on Discord is not really a good idea. Yeah, good luck with that. That actually sounds like a huge pain. Let me go ahead and, this is up. Right, let's talk. So, as you guys know, I'm sure you guys all are well aware, because this is probably the only, this is the only thing that's been on people's minds for the past, like, a month or something like that. But you guys know how it is. I just wanted to show you guys something. This is an app I've been using to kind of track the cases of coronavirus around the world. I think it's quite nice. But the thing I wanted to tell you guys about, where I'm in the U.S. right now. I've been in the U.S. since the start of the year, before I lived in Japan. Now, Japan, let me just show you this. This is actually rather remarkable. So go to China, and you'll see this. Can I move this over there? I don't know if I can. You'll see a growth rate that looks like this for China. It starts off kind of exponentially growing a bit, decays off, grows again, and then decays off finally over here. If you look at, let's take a look at Italy, for example. You see this very, very strongly exponentially growing curve. And if you look at any other country, you'll basically see the same exponential growth. Now, Japan's a bit weird in that it's not as strong as some of the other countries, which is kind of interesting. But the one that's really scary is the US. Okay, so look at how freaking sharp this peak is. Look, it goes nothing, 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 and then shoo, straight up, right? Now, if you compare this to Italy, right? Let's just compare that to Italy here. Italy's, it still goes straight up like that. But it doesn't spike nearly as high, right? Like, it's not like in 3 days it just went incredibly high. You can see the growth here, right? Whereas with the US, no, it's just like from yesterday to today, there's a phenomenal growth. So I just want to point out that if you guys are in the US and you guys are considering going outside, doing your normal things, I would strongly consider maybe not doing that. And maybe just, doing something different that you maybe, I don't know what I'm trying to say here. What I'm trying to say is that if you are in the US and you are not really taking this seriously, I think probably you should. There's not an option here to plot it logarithmically. That's one of the big, I agree that that's a flaw with this particular app. I think if we could plot it logarithmically, we could see a lot more, but yeah. Why does no one fix those numbers? I'm sorry. Right. So here what we have is stay at home and rewatch Leo's video. Yeah, maybe. I don't have enough videos for that. Watch 3 Blue and Brown. He's got a lot of good content. Actually, America opening borders wouldn't be that bad. What do you mean it wouldn't be that bad? Because people wouldn't go to America or go from America. I watched a video a video about that from Thunderfoot yesterday. He said the US is pretty much a month from total infection if they do business as usual. Right, yeah. I believe that's about right. Because no one is going to come to you. Maybe, yeah, that's true. But yeah, so here's the total. Like, worldwide infected cases, period. You can see that up until about this point here, we were dominated by China, right? So this, until about here, this is basically all Chinese numbers. And then we passed China, and now we are, and here's, China has 79K, and worldwide we're at 380K. So we're at, what is that? 14. We're at least 4 times China now worldwide. And the US alone is number 3. Now, I know the US doesn't like being number 3. They're going to get up to number 1 pretty soon if they keep up this trend. But yeah, it's not looking very good. So again, if you are maybe not taking this very seriously, you're not considering socially distancing, you're not considering, the effects of the virus, just keep in mind, most people will be affected. Now, again, if you're young and you're healthy and all that kind of stuff, it won't really affect you too much. Like, statistically speaking, it's not going to kill young people. It's going to hurt more older people and immunocompromised, as every virus does. Now, that doesn't mean you won't be clogging up the hospital system as a kid. You definitely will. But it's just a matter of just staying inside for a bit longer. And I think it's important to keep that in mind. Now, another reason why I bring this up is because just earlier today, let me just go on Twitter real quick. You want to know the number one trending topic on Twitter right now? It's Easter. As much as this sucks, Trump has basically said that he would like to open the United States by Easter. That's what he says, right? And so now this Easter algorithm thing is, I promise you, it's not political. We're not talking about this too much. I just wanted to say that this particular stream is not going to focus anything about politics. I'm just going to say that, hey, if you are being affected by COVID, or you're maybe considering not taking it seriously, you definitely should take it seriously. And if you want to talk about politics, you can talk about politics in the stream chat. But know that this isn't a politics stream. It's a stream about other things. So just keep that in mind. This is actually about calculating the date of Easter. It's not anything about politics or anything like that. Hey, it's E252. How are you? It's not going to kill you. It's going to kill your grandparents and parents. Yeah, see, that's the fear, right? And there is still a chance that you land in the intensive care unit if you're 16. Right. Yeah, there's still a chance, right? I haven't left my house for over 5 years. Don't plan to. Yeah, I mean, that's... Admittedly, if you're watching a programming stream on Twitch, more than likely, that's your mentality, right? Like, more than likely, you're probably not the person to be going out and going to spring break in Florida and all that kind of stuff. But I just wanted to point out, it is something that's seriously affecting a lot of people. It's going to have very strong negative impacts on the economy. And it's stuff that, we're just going to have to wait it out and see how it goes. Personally, I'm really worried about the impacts to the economy, and so when Trump says he wants to open up the U.S. again in Easter, I realize it's a really rushed deadline. But on the other hand, I understand the point, right? This thing is tanking the economy quickly, and this is going to have lasting impacts. And I don't know what those impacts are going to be. Is it going to be another recession? Is it going to be a depression? I don't know. All I know is that it's going to really, really hurt. And we don't know what it's gonna look like for the next year or two. It's gonna hurt a lot of people. I don't know how badly, or how we're gonna recover from it exactly. Hey, Ethel, how are you? Unless you have other illnesses, most likely you won't land in the ICU. Yeah, most likely, but there's still the chance, right? Not only that, but a programmer also tends to be a bit more rational in general, just because they have to deal with logic every day. As a bioinformatician, at least I have job security in these times. See, that's the thing. I'm actually worried that I don't have job security, right? So I'm a postdoc, right? And you'd think that, they're not going to close colleges, right? But on the other hand, colleges and universities are in kind of a bit of a bubble right now, right? So if, funding is going to be cut to any national resource, I don't know. I think maybe the academic system will take a hit. We won't have as much grant money going around, which means fewer jobs, which means more competition, which means I'm kind of screwed. In some sense, I kind of feel like my YouTube career is more sustainable now than my academic content. Because as an academic, I kind of feel like I can see grant funding dropping pretty quickly. But now I think people are really starting to see a need for online educational content more than they ever have before because of the online classes and everything. So I don't know. It's kind of a weird thing, Paxington, thank you so much for following. Really appreciate it. Most likely, but unlikely things happen all the time. Right. I think funding will be cut to non-COVID related areas for sure. Well, right, for the next few months, right? But the question is, how does it affect us in the next few years? And that's what I'm afraid of. I'm afraid that, look, this is a huge dip. If you look at, I keep going to the Dow index. I know there are better indices out there, but if you go to the Dow index, it's just such a big dip. Today wasn't so bad. Actually, that's not so bad. 5 days isn't so bad. A month, 6 months. The one that looks bad is the 5 years, right? Let's just go to 5 years here. It was up and up. We're actually down to about where we were when Trump took office. All of the growth that we've had over the past 4 years has just plummeted in the last month. And that is going to have lasting impacts. I don't know what those impacts are going to be. but I know it's going to have lasting impacts. So what I'm saying is, if you're one of the people who have been affected by this, if you've lost your job or you've something has happened, just do your best to maintain normalcy. Keep yourself physically active. Try to do something creative with your time. I don't know. It's just a rough situation for a lot of people. One of my friends who works in HPC just recently was told not that they're getting laid off, but that their company cannot hire or cannot fund anybody during the time of the COVID virus and everything going around. So, like, the fact that she's working in HPC, which you'd think would be incredibly stable, and is unrelated to this at all because most people could work remotely anyway, it's just a weird situation. Like, a lot of people are being affected by this, not just because of reasons you might not even think about, Let's see. If you're a teen and have healthy immune system, it's near impossible to land in the ICU. Right, yeah, near impossible. But again, things have happened. It could happen. Can you go into industry pretty easily? I think I could, but I mean, this is another issue, right? Like, I need to up my CV for that as well. Australia is in pretty crappy shape when it comes to science funding anyway. $1 is 60 US cents. Yeah, I guess that's right, though, as far as being bad for science funding. Grant money dropping, even if fundamental research needs to be funded, maybe even more than ever. Could be. Yeah, I don't know. This is things I don't know. Not in America. Hewitt Tuilpok, I cannot pronounce that name. I think it's near a global recession. Right, I'm afraid. I am genuinely afraid that this might not be just recession level. This might be even worse than that. And that's what I'm afraid of. Like, I'm afraid that, like, this might be one of the worst recessions we've seen since, like, literally the Great Depression. Like, that's what I'm worried about. And I know I'm being very... I shouldn't worry about that. Like, it's probably fine. There's almost certainly no issue. Like, it's not going to get that bad. But at the same time, it could. We've been there before, Oh, bother. How are you, man? It's been ages. I have not been able to tune into your stream lately, but you are a wonderful person. Hey, welcome to Simuleos, everyone who just rated from Oh Bother's stream. If you guys don't know who Oh Bother is, definitely check him out. He is a wonderful streamer. Like, genuinely just he's just such a nice guy. You hang out with him and you just want to just build circuits. I don't know. He's just such a nice guy. Definitely hang out with him if you can. So go follow him if you haven't already. Today, we're actually talking about Gauss's Easter algorithm. I know I have COVID stuff up here. The only reason I have this stuff up is because recently Trump was talking about Easter and all that kind of stuff. We were talking about the impacts of this long term, but I think we'll go ahead and get started with the Easter algorithm now because I don't want to dip too far into this. I don't want this to become a political stream. I just want to kind of chat and hang out and talk about Easter algorithms and stuff like that. Let me go ahead and catch up on chat here, and then we'll move on to the next topic, which is actually, we're basically starting today's stream, so, like, you guys came at the perfect time. Let's see. Especially if this continues for much longer. For the last 6 months, we're definitely in trouble. Right, that's what I'm afraid of for the economy. A lot of people, okay, at least other people share my fear with the economy. I'm not the only one. It's about the fact that young people spreading it affects older people and immunocompromised people. Let's see. But wasn't there already talks of a possible recession before COVID-19? Right. That's what makes it even scarier. Anyway, we're not going to talk about this too much more. I don't want to talk too much about, like, scary effects of COVID over the next few years. I want to talk about Gauss's Easter algorithm. So for those of you who may not have been here before, let me go ahead and open up Zernal PP here. And let's talk about what Easter is and where we're going with it, why it's interesting, all this kind of stuff. Right. So if you guys don't know Easter, those are circles. Let me try that again. Not circles. Easter. Easter's a holiday, right? I mean, if you guys don't know what Easter is, I guess you wouldn't have been going to stores recently because, like, if you go to a store, there's all these eggs and everything celebrating Easter. On the one hand, I realize that, you probably should be staying away from stores, but that's another issue entirely. Easter's a holiday that's held every year, sometime in March, or April, right? Now, the thing is, this whole conversation started a while ago when my girlfriend basically asked me when Easter was, right? Because she was planning a trip and she wanted to make sure she wasn't bothering anyone around Easter time. And I said, I have no idea. And she got on to me. She was like, hey, aren't you a Christian guy? Didn't you grow up as a Christian? Shouldn't you know when Easter is, is your culture? And I was like, whoa. Easter is complicated. And she didn't believe me, right? And so then I was like, look, I bet there are algorithms to calculate the date of Easter. And oh boy, was I right. So Easter is held Easter is held the first Sunday after the first full moon of spring. Right. So this is two components to it, right? First, you've got to find the first full moon of spring, and then you've got to find the first Sunday after that, right? That's the whole deal. That's the shtick. That's why Easter is actually complicated to do. Now, you might be thinking, come on, we've got computers. We've got, good numerical systems. Surely we're able to calculate this. And the answer is yes, we can. But the truth is, it wasn't until maybe 1800 or so that we really got a grasp on how to do this effectively. By the way, Jacob and Kenko Matix, thank you so much for following. I really appreciate it. So let me explain. Around 300 AD, well, maybe before 300 AD. Let's see. The Pope basically dictated the date of Easter every day or every year. He'd be like, hey, Easter's got to be on this day, and people just went with the Pope. But at some point, the church got really distributed, and it was hard to kind of say, hey, when is Easter exactly? So they had to come up with numerical methods to calculate, the date of Easter. Okay, so where does this lead us? Where does this lead to? Essentially, this one question of how to calculate Easter was basically the only thing people were calculating during this time. It was so important that people started calling it computus, which just means the computation, right? So this was the thing people were computing at the time. And it fundamentally pushed the boundary of human knowledge for centuries, if not millennia, people trying to calculate just the date of Easter. Because again, this calculation of, taking what is a lunar calendar here, this is going to be my moon picture. Yep, that's the moon. Yep, let's just go with that. To the Gregorian calendar that we have here. I don't know how to draw a calendar, so I'm just going to pretend this is a calendar. But this is our normal calendar that we... Okay, that's our calendar. So going from the lunar calendar to our regular Gregorian calendar, which is a calendar that we use every day, is not a trivial task. This calculation spawned the development of not only one, but two calendar systems, and just changed how we think about things. Now, the way that I see it is a nice laptop, right? So actually, there's this guy. His name is Gauss. I'm sure you've heard about Gauss before. If you haven't, let me just talk to you a little bit about who he is. He is one of the greatest mathematicians, I would reckon, of all time. He developed Gauss's law, which is fundamental for electromagnetism. He also developed the fast Fourier transform method before Cooley and Tukey were around. He was the original FFT guy. He did so many things. It's just impossible to talk about mathematics, about the current state of mathematics in today's world without bringing Gauss up. He's done so many things. Gaussian elimination. He came up with his own Gaussian distributions, right? He came up with his own algorithm to calculate the date of Easter. He made it in 1800. 1800, right? Well, turns out his 1800 algorithm was kind of wrong, so he made another one at, I think, 1805, and then another one in 1807, and then another one at 11, and then finally, one of his students corrected him, and I think he got the right date around 1815. Something like this. So Gauss, one of the smartest mathematicians of his time, fundamentally had a lot of trouble getting this problem correctly, getting this problem solved correctly, and he had to do it 5 different times. So if you're thinking that this problem is straightforward, it should be easy to do, just remember that Gauss, again, really smart guy, had trouble with it, right? So I'm kind of prefacing this, or I'm saying that if there's anything that I say or do during this stream that you have questions on, look, it's not an easy question. It's not an easy problem. Feel free to let me know if you have any questions, and I'll do my best to answer them as soon as I get through them, or as soon as I see them in chat. AEOIUW and Photub, thank you so much for following. Really appreciate it. Nice laptop, not bad. Actually, my mom hasn't. Wait, what? What are we talking about? I missed something. Let's see. Join us Discord. Price of mathematics. It's not clicking with me. I'm going to need an illustration of what Gauss looked like. Oh, yeah. Okay. I can give you a picture of what Gauss looked like. Let me just Google Gauss. So interesting thing about this algorithm here. So apparently Gauss didn't know his actual birthday. Like this is the legend. This is the story. Gauss didn't know his actual birthday. He just knew he was born 7 days before Ascension Day on a Wednesday in 1777, right? So what he did is he calculated He calculated Easter with the Easter algorithm, and then he used that same algorithm to calculate his own birthday. That's what he did. That's a story. Although, admittedly, I'm not sure exactly how this algorithm can calculate his birthday. I need to kind of figure that one out. But it's one of those interesting stories of history, you know? Looks like Scrooge a bit. What does Scrooge look like? Duck. Ah, you're right. It does. I mean, if you look really closely, let me just scroll in. Yeah, I mean, if you look really closely, they've got the same like beak structure, I think. I'm sorry, I'm just being a jerk. Okay, the likeness is uncanny. He looks like a penny. How do they look like a penny? Let's see. Ebenezer Scrooge. They both have yellow feet and feathers. The feathers right here. Oh, crap. Oh, no. There is feathers right there. Okay, so let's start talking about the algorithm itself. We'll talk about where we're at. And basically, the idea here is that by the end of today, I want to have a good grasp on the visualizations that we're doing. I want to know where we're going. I want to have the visualizations mostly sorted out, and then we can get ready to put this into the algorithm archive and also on my YouTube channel for the next video, which is hopefully coming out this Sunday. That's my goal. Because most Christian holidays are based on the date of Easter, the date of Easter was needed. Well, right. I mean, the date of Easter was fundamental to the Christian calendar. It's fundamental to so many things. Like, no doubt that the date of Easter was an important thing to calculate for them. I'm just saying that nowadays we look back and we kind of trivialize it, like we trivialize so many things. But it's actually fundamentally interesting in many different ways. And I'm hoping if you're here and you're hanging out and you're, you know, I don't know, maybe socially isolated, whatever you're doing, I'm hoping that you know, you find this interesting and you hang out, chat, and maybe join us on Discord, this type of stuff. Okay, so let's go ahead and open up this. So we're going to go to computers. And I'm going to also look for one more thing, which is going to be Servoius's table. And we'll talk about where we're at. Let's go here and G. Okay. So Gauss's... Let's try that one again. One second. Just Google this. I'm on Google already. Servoius table. Oh boy. It's going to be a long day. Anyway. So let's talk about Gauss's Easter algorithm. We're going to go up here, and we're just going to scroll down, all the way down to algorithms. And then we'll talk about Gauss's Easter algorithm, talk about how we're going to implement it, all this kind of stuff. And it is right here. Okay, so this is actually, let me increase it so you guys can see what we're talking about. Oh, that's the wrong way. Increase it. This should be big enough. Probably too big. Make it a bit smaller. Okay. So this, wait, I think that's as big as I can make it so the table still fits on the screen, but maybe a bit bigger. Maybe, there we go. That's as big as I can make it. So this right here is the Easter algorithm, right? So the idea is we calculate A, B, C, D, E, K, Q, P, M, and N. I think the alphabet worked a bit different during that time. But essentially, yeah, we calculate all these dates, all of which mean something important. Now, what they mean and why they mean those things is the purpose of today's stream. That's what we're trying to figure out. We're trying to find a good way to explain what all of these numbers are. And that's what we're going to go for. By the way, peace in life. I feel like your name before was the real peace in life. And I feel like, is that true? Or is this completely unrelated? Are you a completely different person? Because I'm now... Maybe you were always peace in life, and for some reason I just called you the real peace in life. Oh no. No, wait. If you're peace in life, and the other one's the real peace in life, I got it. It's like how Trump's Twitter handle is real Donald Trump. I got it. I understand. Okay. So let's go ahead and talk about where we're at. So I'm going to go ahead and CD. Ooh, let's try that again. CD into projects, Simuleos, and we're just going to go into computers. I'm going to go into VI Gauss, Easter.jl, and I'm going to open up Julia over here in this terminal. Now, I don't think you can really read the terminal on the left. Don't forget about the real Slim Shady. Actually, I have forgotten about the real Slim Shady. Who is that? The real Peace in Life was a guy who was on some big camping trip. I don't remember. The thing is, I do my best to remember everyone that appears in chat. Like, I really do what I can. But I'm not the best at it, and sometimes I just completely forget people, and I feel really bad about it. So Yeah. Anyway, let's go. So I'm going to go ahead and run include, and we're just going to include Gauss Easter. I'm in the wrong directory. CD projects, projects, Simuleos, and Computus. There we go. And now we're going to run Julia. And we're just going to include, come on, include. And it should be gausseaster.jl. Okay. And that tells us 13th of April, which is the date of Easter for 1800. If we type in Computus, let's see, Computus of 2020, it'll give us the correct date for this year, which is April 20th. Now, what I want to do is I want to actually create a table of dates known as Cervois's table, and I'll bring that up in just a second. So instead of returning that date, I'm going to include another date, right? So the date I'm returning now is not the date of Easter, but the date of the full moon, right? So it says the 9th, which means the full moon is going to be happening on the 9th of April in 2020. And then the next Sunday is going to be Easter. So that's kind of how it works. Let's see. Mom Spaghetti, let's see. First time I see Julia in action. Well, glad. I am glad to hear that. Man, I am so tired. It's been a long day, guys. I'm tired. If you guys have any questions about Julia, how it works, why it works that way, yeah, feel free to let me know and I can answer those questions. I do a lot of Julia development. My primary work is in Julia nowadays, which I'm kind of happy about. My primary work used to be in C++, and man, it's fine. Like C++ is fine. It's so much faster to get stuff done in Julia, and because it's just as fast, it's kind of like, why not use Julia, you know? It's just much better for the type of stuff that I do, HPC stuff. Okay, so what I'm going to do now, speaking of which, before continuing on that topic, I have gotten permission from my boss, and I guess a few other people would like this as well, to do some live streams of my current work, which, if you don't know, is on Klima. It's a climate machine. So it's a climate simulation, and I have kind of considered doing a stream here on Twitch at maybe 4 o'clock p.m. Eastern time or something like that. So I'd go from 4 to 6 doing Klima stuff, and then I'd go from 6 to 8 doing my usual stuff. It's something I'm considering doing in the near future. I'm also considering maybe going down to Alabama to finish up my quarantine there, but we'll see how it goes. Calper, thanks so much for following, really appreciate it. Okay, so I'm going to do over here is I'm just going to clear this terminal so it's up top. And I'm going to create a set of dates, which is going to be, I'm just going to say it's from, let's see. Oh, I know it's here somewhere. Here it is. So I'm going to say it's a set of dates from 1800 to 1899. You saw that the Computus function will return the day of the full moon. So I'm going to go ahead and run Computus dot on A, which is the array I just created. And I'm going to create a set of dates, which is going to be equal to that. Okay? Now I'm going to reshape those dates by saying reshaped dates is going to be equal to reshaped dates 1010. And so what I did is I created a full set of years from 1800 to 1899. And then I calculated all the dates of Easter for all of those times. Or not Easter, calculated all the dates of the Paschal full moon, which is the first full moon after the after spring starts, and then I put them down here in this array. So if I go over here to Cervois's table, this is the first application of Gauss's Easter algorithm. Let me go ahead and open up the view image here, which basically says we have the decade over here, so 1800, 1810, 1820, 1830, and then we have the specific year along the x-axis, so 1800, 1801, 1802, 1803, so on and so forth. And you see that maybe you can't because the numbers are small, but basically we have a working method. We have 9, 18, 29, so on and so forth. All the numbers basically match. So we've accurately recreated this table. And what I'm trying to do right now is I'm trying to find a good way to visualize this. So let's go ahead and do using plots. And I'm going to show a heat map of this. And then we'll think about whether this is actually worth showing, right? So the question is, how do we represent this method in a way that makes sense? And that's kind of where I'm at right now. What do we do to this algorithm to make it clear and concise and understandable for most people? And I'm thinking about a lot of different things that we could do with calendars and things like that. I'm not really sure. This is kind of the bulk of today's stream, trying to figure out how we want to do that. And so here you see That's the table. It's just in some blue shades and stuff like that. Now, one thing that's kind of interesting, I guess I'll move this over here. There's some, where can I put this so that it, I had the same problem yesterday. I can put it down here, I guess. Okay, maybe, here. Now, I have no idea where to put it. I'm just going to close it for now. But there's some dates here that it's kind of ambiguous as to whether these dates happened in April or March, right? So we know that the earliest date of the full moon would be the 21st, right? So this 21st here, in this little area down here, let me see if I can scroll in a bit. So this 21 here is probably the 21st of March, which means the 22nd of March would be the Easter that year at the earliest or something like that. But on the other hand, this could also be the 21st of April, and this is what I'm not really sure about. I need to kind of think about how we read these dates. Actually, now that I think about it, a lunar month is 30 days. So probably, no matter what number they put down, it's probably okay. You know, probably don't get any matching numbers. It's just that the range of Easter is a bit longer. Is this table the result of using Easter algorithm for all those years and an input into the algorithm? Right. So it's like 1800. We put it into the Easter algorithm and we get the 9th for the day of the full moon. 1811, again, same thing. So basically, again, what I did is I took all the dates. So if I read A out, A is just a list from 1800 to 1899, right? And so then I ran the Easter algorithm on all of these guys. So I said, what was it? It was dates is going to be equal to computus dot of A, which means I'm using computus, which is this method in here, function computus, on every single one of those dates specifically, right? If it is less than or equal to 21, then it's April. Lunar month is 29 days. Right, yeah, so I think you're right. I was thinking, so what I was afraid of was the following. So if we go to computus over here, and we just scroll up to one of the images here, right? We see a distribution, which is greater than 30 days. So this date to that day is greater than 30 days. But there's this kind of movement here. So I think the lunar full moons can't repeat. But I think that the dates of Easter could. So like, for example, you could have a 22, which could mean March 22nd or April 22nd. But I don't think you could have a 22 that would mean the full moon happens on the 22nd of March or the 22nd of April. Does that make sense? Like, I think the moons can't overlap, but the Easter dates can. Okay, nice. So, cool. So the point of this table was just to allow priests or I guess whatever, bishops, whoever was calculating the date of Easter to easily look up what the date of Easter would be for this year. That was the whole point. It was apparently wildly popular enough for people to remember it. So that's something. Like, I'm not going to be popular enough that people are going to remember me. So, you know, depends on how you count months, about 29, 30, yeah. So let's go ahead and go through the algorithm and talk about each of the different variables. And let's think about ways in which we can make this more concise. We can make it cleaner and more understandable to people who would be learning this algorithm for the first time. Again, the goal here is to put it into the Easter algorithm, or put it into the algorithm archive. Hey, Uncle Bill, how are you? And right, and then make a video on it, all this kind of stuff. There's a lot of stuff that I want to talk about here. So we'll see how it goes. So let me go back over here. The way this method works is we have a bunch of different variables that we calculate, right? It's essentially, I mean, it's a calculation, right? More than it is an algorithm. It's still an algorithm, you know? So we have to kind of, I'm curious to see what you guys think about this. So the characters here, A, K, P, Q, M, N, so on and so forth. These are the variables in which Gauss used, right? This is a historical algorithm. So I kind of feel like we should probably also use the same variables that the literature typically uses. But at the same time, I mean, the programmer in me really wants to change A from being A to something like year's lunar position or something like this. It's something that makes a bit more sense. And I'm curious to hear what you guys think. Should we keep the character variable names like A, K, P, Q, M, this kind of stuff? Or do you think we should try to make the variable names more expressive? I'm kind of 50-50 on that one. And I'm not sure the best way to do it. Multitasker fail. Sorry, I missed the raid. Oh no big deal. Thanks for coming along. Right, and again, if you guys have questions about anything that I say today, just feel free to ask. I'll do what I can to answer them. So if you guys don't have any strong opinions on this, I guess I'll try to keep the variables as they are and see if we can make that a bit better. It's more expressive with an underscore a at the end. Wait. Of course. Could do letter plus description. Right, so you guys think description. So do we actually have Gauss's original paper on this? That's the question. We should give those variable real names. Anthony, Kelly, Patrick, Quentin. That's what we'll do. So A will be Anthony, K will be Kelly, P. Oh, you actually got the, okay, I see, yeah. You're right, it looks like something an old math professor would write. Yeah, right. Let's be good programmers. Right, we can try that. So I've got a lot I need to learn about this, and I haven't really made too much progress since yesterday. I had a long meeting, so I wasn't able to really stream yesterday, and then I kind of got sidetracked with other things. I wasn't able to make too much progress yesterday, so I'm hoping to make some progress tonight and see where we can get. Again, I do understand that this stream might not be for everyone, so if you guys have specific comments, questions, concerns, ideas, anything you want to talk about, please feel free to let me know, and I'll totally answer them as soon as I see them in chat. Let's see. Keeping the variable names consistent with the original means it's easier to refer back to the algorithm, though. I think it'd be a little better to have expressive names if you want to put it in the algorithm archive. Q goes up for 400 years, you have a leap day. Q is just K over 4. So Q means every 400 years you have a leap day. 1 second. 4. I think, every 4 years you have a leap day would be it, right? Let's see. Tim, 19862. Thank you so much for following. Really appreciate it. Okay, so let's just go through and let's talk about what all these mean, right? So A right here is the year's position on a 19-year lunar phase cycle. I'm going to Google this because I don't actually know what the 19-year lunar phase cycle means. 19-year lunar phase cycle. This is what I got to figure out, you know? I got into a programming stream earlier. Looked like homework. I was about to comment how seemingly programming courses today are still as horrid as I remember from 2 decades ago. Then I saw the stream description. I'm a full stack developer and a professor. I silently left horrified. Oh, I'm sorry. The truth is, when it comes to academic work, right? There's a clear difference between people who write code for academic work and people who write code for even research work and people who write code for, I would say industry, right? Like there's a whole bunch of different practices and stuff. I already read the section below. I definitely read that section. But what I'm saying is that what they say for that, let's just go here. Where's A? It says exactly what I commented. A is the year's position on the 19-year lunar phase cycle, in which by assuming the moon's movement relative to Earth repeats every 19 calendar years, right? In older times, 19 calendar years were equated to 235 lunar months, which is remarkably close to 235 lunar months, and are approximately 6, what was I saying? Wow, okay. 6939.6813 days and 19 years are on average similar to that. The expression 19a plus m mod 30 repeats every 19 years within each century as m is determined per century. I was hoping to get kind of more of a visual depiction, you know, like something that, because this is known as a Metonic Cycle, right? I think that's the same thing. So I kind of wanted to learn a bit more about this because I think, yeah, this is the same thing. A Metonic Cycle is a period of 19 years after the phases of the moon occur the same day of the year. So I wanted to learn a bit more about the Metonic Cycle. That's kind of where I'm at right now. Because I don't think this, maybe I'm wrong, maybe I missed that, but I don't think this actually talks so much about, it just mentions that it is the Metonic Cycle. But I just want to learn a bit about it, you know? Read at least the description on Wikipedia and kind of think about it a bit. Before moving on, right? Famous 6, thank you so much for following. Really appreciate it. Okay, so the Metonic Cycle, or Ennead Ceteris? I don't know, I can't pronounce it. Is a period of 19 years after which the phases of the moon occur on the same day of the year. The occurrence is not perfect, and precise observation shows that there is a lag of about an hour, which would accumulate through a series of cycles. The Metonic Cycle is defined as 235 synodic lunar months, a period of which is just 1 hour, 27 minutes, 37 seconds longer than 19 tropical years. Using these integer numbers facilitates the construction of lunisolar calendar. A tropical year is longer than 12 lunar months and shorter than 13 of them. Okay, thanks for that. The arithmetical equality 12 by 12 plus 7 times 13 equals 235 allows to see that a combination of 12 shorter months and years and 7 longer 13 months. So okay, this thing right here, this allows 2 really bugs me. Like, really bugs me. I don't know why, but it just... The arithmetic equality, this, allows one, allows someone, allows... There's no object in the sentence to see the combination of 12 shorter. Like, it's... I don't know. Does it bug anyone else? It really bugs me. Like, a lot of people use it in academic literature, and it's just like... Every time I see it, it's like there's no object in that sentence anymore. Like, I don't know. I don't know if that... Maybe I'm the only one that it bugs. Let's see. This algorithm needs to account for the slowing of Earth's rotation. We could probably add that. Decateris. Yeah, maybe. You should think about how adding a spot for donations for your algorithm archive and stream now that you're legally able to do so. Yeah, so technically it is in the algorithm archive. If you go to github.com, and technically it's also on stream. If you scroll down, I should have a donation link. Somewhere. Yeah, it's right here. I've got a little box for tips and donations. And over here, if you go to the algorithm archive, I technically have a... Oh, did that not get merged in? Spons. Oh, maybe it's not merged in. Maybe not. That would explain some things. Adding funding, not YML file. Yeah, this was never merged in, so... right, because I had a discussion about what I should do with any of the money I get from it. Yeah, we can talk about that. It doesn't bug me. It allows you to conclude that. Yeah, but there's no... Yeah, it's... I mean, you could argue it's second person. Allowing something is a very active thing to do. Equations aren't active things. I think it's about the allows. Right, so let me just read that again. So, the arithmetic equality... It's just... Okay, so if you tell me this is a second person sentence, I will allow that. If you say that this sentence is supposed to be in second person and there's an implied you, I could almost agree with that. But the fact is this is regularly written in scientific papers where you don't use second person. So I don't know. You take the thing out of the FAQs that say you didn't allow donations. Yeah, I could actually remove that right now. Yeah, I can do that right now. I mean, thanks for reminding me. I completely... Oh, that's broadcast options. How do I change this? Edit panels? Wow. I haven't done this in so long. It's like I don't even try to keep this thing updated. I can't promote my stuff. Why is your code so ugly? Why are you so ugly? What did I even... When did I write this? What was I doing? Yeah, I'll take donations now. Why not? Sounds good to me. Submit. Okay. And then edit panels. Okay, so I removed it. Technically, I'm able to accept donations. I'm not encouraging anyone to donate. I'm just saying that I do technically accept donations now. Kempston, thank you so much for following. Really appreciate it. And we can talk about that later. I'll just move it over here so I remember to deal with it after the stream. Metonic Cycle, let's go. Allowing something is a very active thing to do. You should take the thing. Ticket allows you to enter a party. Or a festival. Right, that's the thing. A ticket allows you to enter. Like, what I'm missing here is when you say this, like, if you say the ticket allows to, that sounds weird. But if you say the ticket allows you to, then I'm like, yeah, okay, I'm fine. Or if it says allows one to, or allows us to, or allows me to, like, there's no object in the sentence. If you say ticket allows to enter, that doesn't make sense. But ticket allows you to enter does make sense, right? Like, my argument is that sentence lacks an object. I'm sorry, I'm going semantical again. I'm not going to turn this into a semicolon discussion. It's fine. Point is, it bugs me whenever I see it, and I see it a lot, and I don't know what to do, like, because I think it's grammatically incorrect. Like, I really do. I'm 100% convinced that it is not correct. No one has been able to justify it in a way that makes sense to me, right? People are like, it sounds okay. I'm like, no, but you're fundamentally missing an object in that sentence, you know? And then they'll be like, the object's implied. It's like, well, it's only implied, again, in the case of you, right? And if it's implied in the case of you, then you're breaking and using second person, right? So it's like you shouldn't be breaking your third person literature or your third person writing to break into second person just so you can say allows to, you know? I don't really care enough, I think. It's just, it bugs me. It bugs me just, where's the subject? Where's the subject in the sentence? The arithmetic equality, this, allows to. Is the equality? No, but that's not the object in this sentence, right? Like, this is, so, like, you could rewrite this so it is the object. You could say, I'm sorry, Doug Russell, thank you so much for following. You could say that the arithmetic equality allows to see a combination of 12 shorter months and 7 longer. Okay, so going back to a ticket allows to enter. Like that sentence is the same. Okay, this is a complete side topic. Okay, this ticket allows to enter. Right? So if you want this ticket to be the subject, then you need to change this to entrance. Right? So then it becomes the subject, right? Yeah, then that would be okay. Because now this is a noun, and this makes logical sense. Right? It's subject, verb, noun. But before you did allows to enter. So then it would be... your proposed subject, verb, and then not adverb, but prepositional phrase, right? So this is not, that's not, now, so the argument is if this is supposed to be the subject, right, and this is the verb, there's something wrong about this sentence structure, because it's like, I don't know, it doesn't, maybe I'm wrong. At the very least, I'm arguing that it doesn't sound right. I think that it is grammatically incorrect to say this ticket allows to enter. I think that's wrong. But yeah, I think this ticket allows entry is fine, right? This law allows selling your property. The laws allow selling your property. Yeah, I guess you're right. I would say the laws allow for selling your property. Okay, fine, whatever. I'm being a bit. Okay, you're right. I know I shouldn't care about this. It's one of those things that I do care about. What webcam are you using? I'm using Logitech something. I think C210. Logitech C210. I think. No, not that one. I'm using a Logitech HD. I don't know. Nope, those aren't it. I don't know. I don't actually know the HD Pro C920. Ah, that's it. A Logitech HD Pro webcam C920. That's what I'm using. There we go. I love this kind of side discussion. I'm sorry, that's like the nature of Simuleus. I always go into side discussion. If it sounds good, it's valid. It's the equality. It seemed fine, now it bugs me. Right. I go for entry. The laws allow selling your property. I'd go for allows entry. Allow to sell. Sounds weird again though. Right. Can we just ignore it? Yeah, okay, we'll just ignore it. We'll just ignore it. I'm not gonna worry about it anymore. Whenever I see it, it always just slightly bugs me. Like to the point that like if I'm writing a scientific paper and that sentence appears, I do everything I can to rewrite the sentence so that doesn't exist. You know, usually it's as easy as adding like a 1, so it allows 1 to see or allows us to see or something like that. That's fine. But like what people typically do is because they don't want to use us in a sentence, they'll remove the us, which they think it makes it sound more proper, but then it makes it so I fundamentally can't read the sentence. It doesn't make sense in my mind anymore. So then I always have to pause as I'm reading it because I have no idea what they're trying to say. Like this sentence just doesn't make sense to me. And then I have to like it always takes an extra second, right? So that's my issue. Anyway, I'm sorry about that. Grins, please, wait. Grins Pills, thank you so much for following. Really appreciate it. Okay, so we're talking about the Metonic Cycle. Let's keep going. No more discussion about grammar or politics or anything else. We're going to keep going. I've got, a bit longer on the stream, so let's go. Okay, so the Metonic Cycle then. There was someone up there, Green Jenny. Green Jenny knows what she's talking about. Eneta decatetris. Eneta decateris. There we go. Thank you so much for that pronunciation. She's probably gone by now. But in the previous stream, she seems to know way more about this. I'm actually very interested to hear what everyone does, for a living, type of thing. I'm interested to hear, what you guys are into, that type of stuff. Just got here, Easter algorithm. Yes, we're talking about how to calculate Easter every year. It's actually kind of complicated. We're talking first about the, what is this? Metonic cycle. And then after that, we're going to talk about, things from there. The conclusion that combination is equal arises from the arithmetic equality 12 plus 13 equals 235. Right, so I'm going to have to reread this one more time because I'm an idiot. So let me just do that, and then I'm going to try to draw its essence out and just throw it down on a piece of paper and say, there you go, that's the Easter algorithm. Okay, let's go. So, apparently, Eneta decateris means 19. Oh, Enechide... Oh, no, that's even harder to pronounce. Enechaidecateris. Why am I so bad at reading words? I just can't. Is a period of 19 years after which the phase of the moon occur on the same day of the year. Is a period of 19 years after which the phases of the moon, there we go, occur on the same day of the year. Okay, so that means that... Okay, so this is a cycle until we see lunar recurrence. Okay, the recurrence is not perfect, and precise observation shows that there is a lag of about an hour, which could accumulate through a series of cycles. So I'm just going to add a comment here and say this is tracking our location. Again, this whole thing is going to be updated. I'm just putting it down somewhere so I remember. This tracks our location on the Metonic cycle, which is a 19-year cycle. Let's see, which is a 19-year cycle until a 19-year cycle that which is a 19-year cycle until, I don't know, lunar phases are on the exact same day as the start of the cycle. I don't know. Again, it doesn't matter. I know what I'm trying to say. I'm just gonna have to put this into the chapter. So A is gonna track where we are on the Metonic cycle. So I would change this maybe to Metonic count or something like this. Something like I would want to call it something like that. I don't know what you guys would want to call it, but we can talk about it a bit later. I wasn't aware calendars were this complicated. Oh boy. I don't think you've heard of astronomy or astrology. They're both apparently very complicated. Let's see. So again, because a couple people have asked Euler 9090 as well, the Easter algorithm here that we're going through is Gauss's Easter algorithm. It's an algorithm that calculates the date of Easter every year. It's one of those surprising historical algorithms that I quite like. It's just cool. Like the fact that Gauss struggled so hard to generate this method is just fundamentally, it's kind of inspiring to me. Metonic index. Yeah, that would also work. Metonic index. Something like that. I personally don't like camel case, but it doesn't matter. 1 second. I'm all over the place now. Right. Okay, cool. Oh, I'm sorry. Let's get back to it. Okay. So next is the century index. This is rather straightforward. All this is I would literally call this century index. Let me keep the old variable names here, and then we will go from there until the lunar phases line up with the solar year again. Wait, so it's not lunar phases lining up with the solar year. It's being the same as so like we had a set of lunar days, we'll say. A set of lunar days. So like in our 365-day calendar, the phase of the moon was this on day 1, and this on day 2, and this on day 3, and this on day 4, so on and so forth. So it's 19 years until we get the same day 1, 2, 3, and 4, right? So it's Okay, so this tracks our location on the Metonic Cycle, which is a 19-year cycle. Okay, where lunar phases are, I'm gonna rewrite that. That's fine. Okay, so here we have P, which is a shift of the Metonic Cycle. This is what I need to think about. So is this, what is 13 plus 8 times K over 25? What does this give us? So K is going to be over 25. Is this giving us the... I think this is giving us this 1 hour, 27 minutes, and 33 seconds. I think that's what it's giving us. So what I'm going to do is I'm going to calculate this variable here. So we're going to do 13 plus 8 divided by 25. Let's see, divided by 25. This gives us 0.84. That seems way longer. Yeah, that's not what we're looking for. I don't think. Nope, I don't think that's right. But this should be, I think this should be that hour that we're looking for, right? So this should give us the shift in the Metonic Cycle, which should just be, right, it should just be this. So this means every 100 years, we get this shift, right? So every 100 years, we're going to shift it that much. And that's going to be, so let's do that divided by 100. So I guess we'll do 25,000. And then we'll say, let's see, that's going to be what in hours? So we're going to divide that, multiply that by, the shift is this many years. So we want to go from that many. Oh crap, I need to think about how we're going to do this conversion, not conversation. Until lunar phases align with solar systems. Yes, I understood. At some point they line up and the 19... Right. This is, I'm sorry. I'm trying to do the same thing you're trying to do, which is like present this, you know? Shouldn't you do 8 divided by 25? Why would it be 8 over 25? Sorry, not the 8. If you teleport 19 years into the future, the date is the same and the lunar phase is the same-ish. Yeah, ish, by an hour off. I had a professor that would leave mocking comments in Snake Case because I would use camel. I'm sorry, that's pretty good trolling. And that's the shift per century. Yeah, so this should be the shift per century, I think. So that's a shift per every 100 years. Which means after how many centuries do we have a full day shift? It looks like after, oh boy, this is stupid. Okay, so let's say after, it looks like after 2 centuries, so after 200 years, so 16 here, we'll have a shift of 1 day, roughly. Is that correct? So it says the Metonic Cycle is defined as 235 synodic lunar months, a period of which is only 1 hour and 27 minutes and 33 seconds longer than 19 tropical years. Okay, so we know it's this much longer every 19 years. So we'll do, oh gosh, I'm not going to do the full conversion here. I'm just going to say 1.5 hours. 1.5 hours every 19 years, right? So that's every year we have a shift of this many hours. Okay. Now let's do 24 divided by that. And we get 304. I don't know why I just did that. Oh, that's how many years it's going to take. No. Crap. No. Yes. That's how many years it's going to take for 1 full day shift. And that is not what I was expecting, but also I think I got the number wrong. This is, no, 1.5 hours is about right. Okay, let me think about that again. I'll just think about it. Okay. 8 over 25 is a shift per century. And every century is 8. Oh, right. So 825 is a shift per century. That is because, yes, that's correct. It has to be about that. And then it's divided by 25 because of what? Why is it divided by 25? Chat, please help. So let's see. I like Python's convention, snake case for objects, camel case for cloud. Is that actually their convention? Oh no. Oh man. Okay, I now understand Python code. Gotta go. See, Amaras, thank you so much for coming in. Have a wonderful evening. It's because 100 isn't divisible by 19. Okay, wait, let me think. Okay. So, but the 25 is because... Okay, I need to think about it a bit. Pep 8 conventions. I never knew Pep 8 was so trolly. Like, honestly, I thought it was like a normal convention, but apparently, no, it's pretty trolly. Okay, so A, we understand. It's some sort of Metonic index. Okay, K, we understand. It's a century index. P is going to be the shift in the Metonic cycle, which should be somehow related to the hour and 30 minutes, basically, that were shifted every 19 years. So let's just do this stupid math here. I'm just going to pull it up, and I'm just going to write it out, because I'm really bad at conversions. So let's do journal, new page before. So it's shifting 1 hour, 1.5 hours, we'll say, every 19 years, right? So in a total of 300 years, how many hours is that? Okay, let's do the math. 1.5 over 19. And then we're going to do that times 300. And we get 23. That is about a day. So we did the calculation right. So in 300 years, we're at about a day. The 13 must be an offset. The 13 must be an offset because the Metonic cycle is off by 13 or something like that. Must be... No, now I'm confused again. No, I'm confused again. So we know that every 300 years or so, this calendar will be 1 day off. Okay, we know that. So then that means that 13 plus 8 times k. 13 plus 8 times k. What does that give us? So 8 times... Let me see if I'm just being dumb here. It might actually have been... It might have mentioned it here, and I just didn't understand it at the time. So let me see if we can figure this out again. I'm just going to look for 13 plus 8. And it's only matching there. Okay, so let's look for the P term. Gauss's Easter algorithm. Right, so I'm just going to search for all the P's. P. No, that's when he incorrectly stated it because Gauss is an idiot, right? No, he's actually one of the smartest people in existence, so I wouldn't say that. I mean, I just did, but don't quote me on that. What am I saying? Let's see. P corrects the lunar orbit for not... P corrects for the lunar orbit not being fully describable in integer terms. There was something about what you said. That was correct, Cropeb. Leap day, every 4 years, unless year is divisible by 100. But it is a leap year if it's divisible by 400. 13 is an offset. 8 divided by 25 is about 1/3. Dumbest genius I've ever read about. By far, he's an incredible person. I'm sure, definitely, subscribe to his YouTube channel, all that kind of stuff. I'd love to collaborate with him in the future, but, he's such a wonderful guy. Definitely check him out. Okay. So what do we have? 8 over 25 is about 1/3. That is correct. That's about 1/3. And you're saying 13 is an offset. So, man, could you imagine if Gauss and Maxwell and all these people had Instagrams or Twitters or YouTube channels? Just imagine that. That Tesla would be doing something crazy. I wonder how similar Tesla would be to the current Elon Musk. That's what I'm wondering. I kind of feel like a lot of these guys have interesting characters, I'm wondering I don't know. So 300 years is 24 over 25 is about a full day. Okay. So, okay, I'm trying to process what you just said. So I follow him on Instagram. That's not what I'm trying to process. 8 over 25 is about 1/3. Okay? So that means every 100 years, right? Every 100 years you have about a third of a day wasted. Fair enough. Okay. Then you have 13 added there for an offset. Okay, fair enough. So you're right. I'm just going to add that in there because I think that's the clearest thing. So 8 over 25. Let's see. Add a day offset until every 300 years. Okay, so here we're going to say 8 over 25 is roughly 1/3. So every 300 years, that will add a day. Again, I'm gonna fix this up. 13 is let's pop this down here. 13 is an offset. Okay, so something like this. I think that's right. Also, you've seen his selfies. I have not actually seen his selfies. 2,500 years makes a full cycle. So on P. So 21 whatever is every 2,500 years. Right. Actually, you're right. So there's going to be some. Well, you're saying every 2,500 years. Every 2,500 years, he's going to be off again. Is that what you're saying? Because I think I'm understanding, but I need it explained. Like, imagine I'm 5. I know I have a PhD, but imagine I'm 5. 8 days every 2,500 years. Oh, right. Okay, that's clear. So 8 days. 8 days off every 25 years. Okay, again, I'm going to update all this. I'm just writing stuff down for me to fix later. I imagine Christ being born 100,000 years earlier, then the century index would be plus 10, so you'd need a different offset, actually. I mean, look, I have no idea. Which is 14 hours every 19 years. Right. So I think there's an interesting note here that says, I think this might be why the algorithm breaks down at 4,200. It's something I want to think about because I'm not sure exactly why it breaks down at that point. Okay. The next is the leap day difference between the Gregorian and Julian calendars, and that is correct. That is exactly what it is. So the Julian calendar doesn't take into account leap days. So here we're taking K, which is again the century index, meaning every 100 years you're going to be 25. No. What? What is this saying? So this says... Oh, no. The Julian calendar does take into account leap days. Oh, well, let me think about this. Julian calendar. The Julian calendar does take into account leap days, right? No, it's just... No, I think the Julian calendar is just 365 days. And the Gregorian calendar is 365.25 days. So that means it was developed as a correction, which shortened the average day by... Or is the Julian calendar... How many days are in the Julian calendar? That's my question. Am I dumb for asking that question? The answer is yes, but P is for the 400-year leap years. Hey, Clone Style, how are you? I hope you're having a wonderful day too. Thanks for coming in. Let's see. Hey, Jerklump, how are you? I think floor 13 might be the same as round 8K over 25. Right, but specifically they did require a floor, not a round. So, let's see. The last man stands. Q. I'm at Q. Wait, crop it. Oh, Q. Q, not P. Yeah, let's see. Compute is here. P corrects for lunar orbits. K minus Q. Oh my gosh, why are all these variable names dumb? Q. What is Q? P corrects for that. And P and Q in my mind look identical. Like I can't tell the difference between P and Q just as characters. And I always get them mixed up. So like Q, I'm looking for Q. Q reinstalls it every 400 years. Okay, what do we have here? It is determined by a calculation taking the number of leap years up until the century where K inhibits a leap day every 100 years and Q reinstalls it every 400 years, yielding K minus Q as the total number of inhibitions to the pattern of leap day every 4 years. Okay. Compress that, put it somewhere. Okay. Leap day difference between Julian and Gregorian calendars is what I wrote down. So K is a century index, K over 4. So if K is 1, then every 400 years, we're going to add 1 day. That's exactly what's happening. P is for 400-year leap years. Ah, right, because every 400 years, you add 2 days. So P adjusts for the additional... Oh! So in this case, Q adjusts for the additional 1 hour, 27 minutes, and 33 seconds. No, P adjusts for... No, you're right before. P adjusts for the additional 1 hour, 27 minutes, and 33 seconds. Q does... Why do we have an additional leap year every 400 years? What's the 400-year leap? What's a 400-year leap year? What is this? Leap year. 400-year leap year. Okay, so what do you have here? For example, in the Gregorian calendar, each leap year has 366 days instead of 365 by extending February to 29 days, rather than the common 28. These extra days occur in each year, which is an integer multiple of 4, except for years evenly divisible by 100, which are not leap years unless evenly divisible by 400. The 100-year skip is, because accuracy. Okay, so this is something I never knew, and so I'm trying to learn this right now. So you're saying that the 400-year leap is not the interesting one. The 100-year leap skip is. So you're saying that every 100 years, so okay, these extra days occur in each year, which is an integer multiple of 4. Okay? Except for years evenly divisible by 100, which are not leap years unless evenly divisible by 400. So this means that every time we have a leap year on 100, like 1800, 1900, 2000, something like this, we do not observe a leap year unless it's divisible by 400. So that means 2000, the year 2000, we did observe a leap year. Am I understanding this correctly? Okay. So this means that let me see if I got this right. Every 400 years, we need to, isn't it subtract 3 leap years? Floor of K over 4. So, K minus Q. So K is going to be, every 400 years we have 100 leap days. Every 400 years we have 100 leap days, minus 3. Okay, so that means every 100 years, so that means every 400 years we have 100 leap days. Right, so K is going to be your century index. So if K times... I'm trying to figure this out. Determinist, imagine numbers, add or subtract. Maybe the Earth not equal each circle? Wait, what? Maybe the Earth... Wait, I'm confused as to what that sentence means. Jerklump, what Windows manager are you using? I'm using OpenBox. It's just OpenBox. I think you probably know about it. Let's see. But what is bigger? I'm disturbing. K minus Q goes up by 3 every 400 years. Does it though? That's my question. The answer is it should. So it goes up by 3 every 400 years. Julian calendar accounted for the inaccuracy in leap day every 4 years and skipped the leap day on the full century. How do you guys know so much more? How do you know so much about calendars? Like, is there like a calendar book I was supposed to read in high school that I just didn't read? The Gregorian calendar added the leap day back every 400-year cycle to add more accuracy. The Gregorian calendar added the leap day. Of course, there's a YouTube video. There's a YouTube video that someone's linking in the chat saying, oh, if you would have just watched this video, like you totally would have understood everything. And I'm going to sit here being the guy that doesn't understand anything from video content. So I just... Of course, it's stand-up math. He's a good guy. I like him, but you know. Okay. So, okay, let's figure this out. So Crop and Slash Life both know what they're doing, and Green Jenny, whatever her name is, also knows. Europe. I thought of that video too. Okay, so what do we have here? We have. Okay, so every 100 years, Q is going to be equal to 1. No, every 400 years, Q is going to be equal to 1, right? So every 400 years, we're subtracting 1 from K. My question is, and this is what I don't understand, this is my question. If every 400 years we're subtracting 1 from K, why are we doing, I don't understand how that makes sense. So P is going to be, K is the number of leap days skipped. Q increases by 1. K is the number, oh, okay. K is the number, so, right. I understand now, right. So this is a century index, right. So this Q shouldn't be thought of as just Q. It should be thought of as K minus Q, right. So K then is going to be, so K is going to go 1, 2, 3, 4 for the 400 index, and then Q is going to subtract 1. That makes sense. So here what I'm going to say is, Q, what is it? So it should be 3. Okay, so, right, so I didn't realize that we'd already assumed we had counted for the leap day. So, okay, so what am I going to do here? I'm going to say every 400 years, there are 97 days, which will be K. No, it's going to be P minus K minus, no, I got this wrong already. Why is it always P plus K then? There are 97, where there are 100, we'll say 97 leap days. K is already century index. So every 4 years, it will, 400 years, will be 4. Q will then subtract 1 from that, and again, this is just, I'm just trying to remember this for later. So Q will then subtract 1 from that, give us 3, so that 100 minus 3 equals 97. Something like this. I don't know what I'm actually going to write, but something like that. Okay, 1900. It wasn't a leap day, so the full moon falls a day later. But now, yeah, I have no idea where we do that. A simple solution, we get a new calendar system that doesn't have this problem. Genius. I feel like we already tried that twice in history. I feel like it didn't work. So that must mean a solar day is 364.2425 days long. Oh, the leap day every 4 years is in B. Yes. Yes, that's down here. Okay. The moon always moves at the same rate. If you skip the leap day, that will get your next year 1 calendar day ahead of the moon. The moon always moves the same rate. If you skip the leap day, that will get your... We're calculating a century constant at the moment. Okay. I think I've kind of got a wrap on this. I need to think about it a bit. But I think I'm kind of still thinking about it. But it makes sense to make K minus Q its own variable and give it a name. K minus Q is what makes the most sense when we think about the calendar. I think you're right. I think it probably does. So I'm going to add that in here. Again, we're kind of thinking about how to write the code right now. So K minus Q. K minus Q should be thought of its own variable. Okay, just writing that down because I agree with you there. Okay, so what do we have here? Correction is starting point of the calendar calculation. So M, now I have to figure out what M is. But we're getting through this. I'm actually pretty happy with how far we've gotten. We're slowly getting through this. M is 19A, serves as to have a correct starting point at the start of each century. So this is the part that gets me, and I think actually these guys did a pretty good job here. This guy, whatever this guy is, I'm going to look for his definition of M. And also let me get some water. So, okay. So I think he had a good description of what M was here. And I'm just going to go through and figure that out. Right. Because of this equality of 235 lunations in 19 years is not really exact. There's a small shift of about 1 day per 310 years. Yeah, we found that out. 8 days per 25 centuries. The value of M takes care of that shift. As far as I know, Gauss did not include a calculation of M in his algorithm. For calculating M, some intermediate results are P equals year div 100. This simply, okay. Right, so you're right. M is the century lunar cycle offset. So all of these variables, which is P, K, and Q, are all used to calculate M. Now, why are we mod 30? Wait, 19 times A plus M. Where's 19? Oh, down here. That's D. Okay. So M is going to be... Look at... So this is adding... And the mod 30 is because... Why are we mod 30? Let's see. They did a mod 30 down there. So why are we mod 30 up there? I found approximately 2 hours an annoying approximation for 1 hour is 27 minutes, 33 seconds. Is that what they said over here? That is an annoying approximation, actually, now that 1.5 hours is closer. I found it. Let's take a look. Of course, there's an XKCD for this, as always. Oop, sorry. Let's go here, there, paste it down. Under my time system, the sun rises at 6 a.m. and it sets at 6 p.m. as it should. The length of the second is different each day and night, and the current time shifts with your latitude and longitude. Today is one of those 2 days each year when my clocks run at the same speed as everyone else's. Time standards are so unfixably messy and complicated. At this point, my impulse is just to try to make them worse. You know how Einstein figured out that the speed of light was constant and everything else had to change for consistency? My theory is like his, except not smart or good. Oh, XKCD, what a wonderful, wonderful comic. Mod 30 is because the lunar cycle is 30 days-ish. Okay. Yeah, I think that's okay. So this is the correct starting point calculation each century. Mod 30. Because the lunar calendar is about 30. Let's see. I'm gonna say this is a sum combination of previous terms. Okay, something like this. I need to figure it out. My mind turns off. Determinism. My mind turned off a super long time ago. I have no idea what I'm doing anymore. Like in life, in general, I don't know what I'm doing. But I'm glad you're here anyway. Feel free just to chat, hang out. Glass of ethanol. I'm using OpenBox. Actually, if you guys are interested in the theme here, it's a specific theme. I can put it up on GitHub. I've been asked for it a few times, and I put it on Discord somewhere. But yeah, it's just a theme for OpenBox. That's all I'm doing. Let's see. Okay, so next is finding the next Sunday. So this is the next section where we're trying to find the next Sunday. Okay. So the difference in the number of leap days between the Gregorian and Julian calendars is going to be 4 plus K minus Q mod 7. So M, so we just calculated M, right? M is going to be the correction to the starting point of the calculation each century mod 30. So I wonder how quickly I could chill a can of beer. There's a way to like super cool it, right? I don't know. I'm not very good at beer and cooling things down. Okay. So let's see. We have the lunar calendar is about 30. I'm okay with this definition so far. So next is finding the next Sunday. The difference in the number of leap days between the Gregorian and Julian calendars would be n. So it's going to be mod 4 plus k minus q. 4 is, so this is where 4 is the number of leap days, and k minus q is the number of additional leap days, right? And then 7 is the day of the week. So 4, number of leap days per year. K minus q is the number of additional leap days. And mod 7 because week. What do we have here? Let's go to evolve again. It's this Easter algorithm. Is it Easter already? No, it's Easter in a few weeks, but the earliest Easter could have been was last Sunday. So I kind of wanted to put a video out this Sunday about it. Is there a link to the Discord anywhere? I don't see it in the channel description. Thanks, Surly Dev. Appreciate that. Okay, cool. So the number of days from March 21st until the full moon is going to be D, and this is the one that's complicated. I don't remember how to do this, so I need to figure that out. 4 is not leap days a year? Oh, that is incorrect. You're right. Crap. What was I thinking? So what is 4 then? 4 is definitely not the number of leap days. Let me just... What is 4? Oh, man. Okay. That was me just being dumb. So 4 then is going to be... N is the first Sunday of the century, I think. Is 4 just an offset? But why do we have k minus q? So k minus q again is going to be the number of leap days. The number of leap days every... Okay, k minus q every 400 years goes up by 3. Okay, 4, what's the 4 for? Yeah, it could just be an offset. Yeah, maybe it's just an offset. Maybe I'm overthinking this. 4 is offset. You read Grim, Trash Talk? I think only the prologue was okay. I think everything else, it needs a lot of work. Like, I'm really, really very far from getting anywhere. But thanks for reading it. Feel free to let me know what you think about it. Right. 4 is the number of days of the first week of the year. What? 4 is also the number of days in the first week of the year? To start counting week 1. Wait, what do you mean? There's a... What? 365 mod 7 is 1. Okay. 365 mod 7 is 1. It was Saturdays, it'd be 3. Why are we starting counting on... Okay, Trash Talk, I appreciate that. Feel free to let me know on Discord, send me a message. The story's weird. The story is just me writing right now. There isn't really much of a story. It's like a really weird one. But I can talk about it if you want. But on Discord, not right now. No, it's super threatening. I understand. But leap days, it would be shift 5. Leap days would be shift 5. Shift 2? Oh boy, I'm lost. I'm confused. So 4 is 4 an offset? That's my only question. I'm so sorry. Oh, you have to remember you're talking to an idiot, right? So, all of those lessons you learned from Explain It Like I'm 5, you have to use them here. Like, it's essential that you use them here. Otherwise, like, I'm going to be completely lost. Everyone's going to be completely lost. It's going to be a hard week. So I'm going to go with 4 is an offset from what? I don't know. So D is the number of days from March 21st until the full moon. And I need to figure out where the 19A comes from. Okay, so now look at D, which is 19 times A plus M. The number 19 we see here does not have the same meaning as the Metonic cycle used to calculate A, but it comes from the following. I know 4 is an offset. I think it's fine. We just know 4 is an offset. It's a magic number. I'm okay with that. Okay, the number 19 we see here does not have the same meaning as the Metonic cycle used to calculate A, but comes from the following. A so-called moon year of 12 moon months is a bit more than 354 days, so it's 11 days shorter than the Gregorian solar year of 365.2425 days. This means that the moon phases occur 11 days earlier every next year, and since a moon month has got 30 days, this implies that the moon phase also occur 19 days later, which is the meaning of the 19 in the calculation of D. The value D handles the Metonic cycle using A. Okay. 19 minus 11 is mod 30. Right. 100% magic number 2. I can give you some numbers. Thanks, man. I'm not going to pass a century, so... Okay. So the number 19 we see here. So what is... So moon year is 12 months. A moon year of 12 months is okay. Moon year equals 12 lunar months, which equals 354 days, which equals 365 minus 11, and minus 11 there we go, perfect math. There we go. Something like this. Okay, and then the M, I feel like there's some fuzzy math there. Like, aren't we off by a quarter day? I feel like we're off by a quarter day by this calculation, which is meaning the 19 year in the calculation D. Oh, no, that's already handled by the, I think that's already handled. Okay. Well, right. I mean, you're right, Crop It, because it's mod 30. They both equal 19. Solve with B. Okay, right. Let me fix it anyway. Quarter year offset. Let's see. I don't want to distract from the problem, but are you on this list under a different name? To your stream name? I don't think I'm even on this list, honestly. Yeah, I tend to, for some reason, people don't put me on lists. I don't know why. Probably because I don't do development. I mean, it could be under J. No, then it'd be under L. No, then I'm under S. No. Yes, I'm not on the list. But yeah, I don't think people typically put me on these streams. Stream names because I'm, I don't do development. I'm not a dev streamer, right? So people tend to be very, like, no one looks at this stream and then they're like, that guy's a good developer. Like, that's not the way this stream usually goes, you know? It's usually more about learning algorithms and stuff like that. So I'm more of an applied math stream than I am a developer stream, right? Which I understand and I admit, I accept that. As much as I would love to be, you know, better. You're a good dev though. I appreciate that. But I think people just don't tend to put me on these lists. I don't know why. Maybe because I don't actively ask to be put on this list, you know? I mean, wait, are people like contributing themselves to this list? Is that what people are doing? It looks like that might be what people are doing. No, I don't know. I'm not sure. Yeah, I'm not sure exactly what people are doing, but I don't know. I don't think these lists are too useful in some cases. Jack Mott. Yeah, I mean, like, look, he's got a YouTube channel. Nice. Yeah, good for him. Anyway, not gonna talk about this. Developers. Oh yeah, people put themselves on. I could put myself on, I guess. Let's schmish. Brandon CC2, thanks so much for following. Really appreciate it. You already have a list on Twitch, right? I'm fine. I'm happy enough being on the list that I'm on. Okay, so now the next things are B and C. So, 52 times 7 is equal to 364, right? But there are 365 days a year. So we're offsetting for this. 2 times B plus 4C will drop by 1 every year, but 2 on leap years. Yes, that's just some mathematical thing that works out. So now if we go down here and we go down and we have ignoring the 6D term, this is the number of days until the next Sunday from March 22nd. 6 times D adds an appropriate offset to the next Sunday. Right, because it's mod 7. Okay, I think then we have appropriately commented this so I can make my chapter in the algorithm archive. I'm happy with that. I think we're at a stage now where I kind of understand it enough that I can start writing this section of the algorithm archive. What I need to think about now, and probably in the next 15 minutes, I'll be finishing up in the next 15 minutes or so. So if you guys have somebody that want me to raid at the end of stream, feel free to let me know. Otherwise, I'll just pick my own streamer. Let me see who's live. Again, it's 15 minutes still, but I like to remind people a bit ahead of time. Adam13531 is still live. We could raid them. Pokori Mio is doing art. I'm a big fan of Pokori Mio. Oh, I must have accidentally clicked your stream. Loading artist. We can see. I feel like Adam will be finishing soon, so I don't necessarily want... I don't know. This is in the sim repo, right? Yeah, I'll go ahead and put this in Simuleos right now so people can take a look. Git add Gauss Easter.jl git commit -m adding a few more comments to help write. Okay. It's just all in the master because I don't care. This is just all scratch code essentially. Brickenick or Tim are who I'll be switching to when you're done. Okay, cool. Thanks for being here. Also, Algoli, Code, Kane, and Flory, thank you so much for following. Really appreciate it. My bet is what I'll be switching to. Yeah, I know it's late for a lot of people, so I hope you guys... thanks for hanging out so late in the evening for people in Europe. I'm surprised anyone from Europe is here, honestly. I'll leave the beer closed then. Okay. So what we need to think about now, we have kind of an idea of how this works, right? So what I need to figure out is how we can make this understandable. So we have the Metonic Cycle, right? Like this can explain to A. Do I just need to redraw the Metonic Cycle? Also, what is this? So we're going to start here. 1, 2, 3, 4, 5, 6. Oh, let's start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. This is the whole Metonic Cycle. Don't know what this means. But man, this is just like... It's like people didn't know how to draw back then or something. Like, man, this is just an ugly diagram. Look at that guy's face. Okay. So this then... what am I doing? Back. So this can help us understand the 19A. And the thing is, I've got a feeling that we're going to be very circular-y if we do it this way, right? Like we're... Okay, I see what this is reading. So this must be each month. So there must be 12 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was expecting it to be 12 out. What if there's a way just to put a calendar up? What if, like, okay. Let's see. The bottom guy with a spike here. Yeah, this is definitely Rick from back in the day. Also, these guys are doing some weird symbol with their hands. I don't know what they're doing exactly, but it's weird. Let's see. Right. So we need to think about this. I could do We could just do a bunch of clocks in some ways. Like we could do, I kind of feel like I want to be able to just like draw a calendar. Like I just want to be able to say, let's just make this, which huge. Let's just do cal of 1800 or something. Here. So I just want to be able to put a calendar up and somehow visualize everything on this calendar. What purpose they set when they were making those, I have no idea what they were trying to do with these calendars. All I know is that this one up here, this upper right-hand one, is 19 elements around, and there's a 19-year Metonic cycle. So my guess is that these guys going outward from the circle indicate like where exactly the moon is going to be that month. I don't know because I can't read the language, but I'm assuming it's something like that. I don't know, but the problem is it's 10 elements that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's only 10 elements that way, so that doesn't make sense if it's every month. And I have no idea what this is. The 10-month Roman calendar. Oh, you're right. If it's a Roman calendar, 10 months. Okay, right. Okay, good. Planets. Oh, that's planets. How many planets do they think we have? 1, 2, 3, 4, 5, 6, 7. Is that 3 planets? There must be 3 primary planets or something like that. On the left. And then if we go down, I don't know. This is just some arcane algorithm if I've ever seen one. Okay, so for example, by the 19-year Metonic cycle, the full moon repeats on or near Christmas Day between 1711 and 2300. A small horizontal libration is visible comparing the appearances, and a red color shows full moons that are also lunar eclipses. Is this what we want to show? Do we want to just show this image and say that this is the day after Christmas every year for 19 years? And then we say, this is the day after Christmas every year for 19 years. And, I can't because it's CC BY share alike. Darn. Because if it's CC BY share alike, then I have to change the license of my YouTube video. And I can't do that because YouTube doesn't allow CC BY SA. I think the big circle is mostly numbers. Also, the innermost thing might be a sequence of long and short lunar years. But now they're delegated to asteroid belt, kind of like Pluto. Dang, I wish I had that data. Maybe I contact the guy? I can send him an email. Maybe I contact him and say, hey, I'd like to use your thing, but because it's CC BY SA, I don't mind making my YouTube video CC, but I can't make it CC BY SA. By the way, Opus000, thanks for following. Really appreciate it. Okay, maybe we can show the Metonic cycle kind of like that. There's something in there for the Metonic cycle, but there's a lot of other things to visualize, right? So, but the question is, do we even need visualization? Can we just go around with adequate descriptions of this? Like, what kind of image am I even looking for? Am I just looking for a plot of the moon's phases every 19 years? Because that's, I don't know how to visualize that at all. Okay. The next one would be for leap days. If I could just take a calendar and we could like describe how many days off. I need to think about this some more. I'm not really sure the best way to do this. Find the next Sunday. So it looks like we have 3 different calendars, right? We've got the lunar calendar. We've got the Gregorian calendar. 4 different calendars, actually. So we've got... Oh, what are we talking about? We have the lunar calendar. We have the traditional yearly Gregorian calendar, the solar calendar, we could call it. We've got the weekly calendar, which we have to keep into account as well. And do we need to keep monthly into account? I don't think we need to keep monthly into account. I think it's okay. Smurf Berry Barbecue, thank you so much for following. Really appreciate it. Okay, I'm adequately confused. I'm hoping that some people got something out of this stream. And I think this is where I'll go ahead and close shop for the day. I'm still trying to process this. And if anybody has like cool visualizations that they want to talk about, or they think about, or they think could work for this, feel free to let me know, because right now I'm kind of drawing a blank. Yeah, I'm not. I just can't. And nor do I even think this needs to be visualized. Maybe we could just get away with some good text. But if I've learned anything from this guy's website, it's that good text doesn't get you very far. Where's this guy's website? It's just like, it's still very difficult to read. Okay, so I think that's going to be it for the day. I figure we can raid. Is Tim live? Or did we raid Tim last time? Who did we raid last time? I kind of feel like I want to raid Adam. Yeah, let's raid Adam. Let's see, what do we have? Okay, yeah, let's raid Adam. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, evening, morning, whatever time it happens to be your time. And Adam 13531. Okay. Thanks guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. Adam's been on for hours already. Oh, do you think he's gonna... Wait, let's cancel this. Let's cancel that real quick. So you think Adam's gonna close shop pretty soon as well? Let's do it anyway. Yeah, I think that's good. Let's go. Let's just raid Adam and we'll see what he does. Worst case scenario, you guys go into another raid from that raid. It's fine. I trust Adam to pick a good guy. Okay. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos, when we actually get the visualizations working. We need to figure something out. So if you have any ideas, please feel free to mention them on Discord, where we can talk a bit more about this. Thanks guys so much for coming in, and I'll see you next time. Bye guys.